folks. My name is Amelia McNamara, and I'm an assistant professor of statistics at the University of St. Thomas in the Department of Computer and Information Sciences. I tweet at Amelia MN, which is a double entendre because my last name is McNamara and I live in Minnesota. And typically I would say I've just tweeted a link to these slides, but I don't know when you're going to be watching this video. So I will say that the slides are online at amelia.mn/syntax if you want to follow along. And I'd like to begin by doing a little bit of a land acknowledgement. Even though this is a virtual conference, I want us all to take a moment and consider the physical space we're each in and the history of the space. The United States is built on land forcibly taken from Native Americans, and where I'm currently physically located is no different. What's now called Minneapolis and St. Paul was originally Dakota land, and we continue to have a vibrant Native community here. I chose this beautiful map of sites in the Twin Cities labeled in the Dakota language to show you where I'm physically grounded. And I'm going to be thinking a little bit about language in this talk, so I think it's particularly appropriate to show you some language. So I'll start off by saying that I am a massive R nerd. This is a photo of me at the RStudio conference. I'm wearing a dress that I made, which is covered in R package hex logos, and I'm standing in front of a wall of hex logos. So I really love programming in and teaching R. And one of the things that makes R really appealing to teach is that if you are interested in teaching reproducibility, there is this thing called RMarkdown, which is a variation of Markdown. So you write in a simple markup language, a pound sign makes a title, text is just text. You can write code chunks that have delimiters, and then there's a process called knitting that turns this RMarkdown document into a nice typeset document. So you get the nice titles, you get the text. Wherever there's code, the code is executed, and then the output of the code is embedded in the document. So if you are not familiar with RMarkdown, I really encourage you to learn. Unfortunately, this talk is not about RMarkdown, but it is about R, and specifically it's about teaching R. So this kind of builds on material from a keynote I gave in the summer of 2020 called Speaking R. And I guess if you wanted to, you could go watch that talk right now. I've linked it here. And it's mostly about how I believe that when we teach programming, we need to be reading code out loud and speaking it. But an aspect of that is the programming syntax or the dialect or the domain-specific language, however you want to call it. So most programming languages only have one correct syntax, but one of the things that makes R as a language really unique is that it has many correct syntaxes. And syntax here is the rules that specify when something is sort of correct and can be run in a particular programming language. So I think of three main syntaxes in R, and I call them the $ or base R syntax, the formula syntax, and then the tidyverse syntax. And I've been thinking about these syntaxes for a number of years now. I actually created this cheat sheet to help my students see what each of the syntaxes kind of looks like, and also to allow them to see that they could translate between these different languages. They're kind of just different ways to say the same thing in R. So if we focus in on some summary statistics, you can see how in the $ or base R syntax, you would do mean, parentheses, MT cars, $ MPG. In the formula syntax, from the Mosaic package, you would write mean, parenthesis, tilde, MPG, comma, data equals MT cars. And in the tidyverse syntax, you would do MT cars, and then, that's how we pronounce the pipe, summarize mean of MPG. And what I'm going to be talking about in this talk has to do with some debate in the statistics education community about which of these syntaxes you should teach. And of course, in the real world, practitioners mix and match the syntaxes here, but it is useful to students to see one consistent syntax and to know that they're going to sort of stay in one column of that cheat sheet, even if they might see other solutions if they search online. So those few examples that I just gave you from my cheat sheet are using an old standard data set from R called mtcars, but the rest of the examples are going to be using this data set from the Palmer Penguins package, which is data about penguins. And I really recommend using this as your default data set. It has cute drawings that go with it, and it has many useful properties for teaching. There are missing values, there's categorical and quantitative variables. It's just a really nice data set to use. So let's focus in on some summary statistics, thinking about summary statistics in these three different ways. So you can see the base approach. If I wanted to take the mean of the body mass of the penguins and find the mean for each species, I would have to either write 3 lines of code, or I'd have to write this sort of complex t-apply statement. Even as someone who's been programming in R for more than a decade, it's very hard for me to come up with the t-apply solution right away. And I think that the repetitive 3-line code is hard for students to grasp. The mixture of square brackets and dollar signs and equals equals, there's just a lot of things that can go wrong there. So a better solution would be to be using the formula mean, parentheses, body mass G tilde species, or you could say body mass by species. Sometimes we pronounce the tilde as a by, common data equal penguins. And then in the tidyverse, penguins, then group by species, then summarize the mean of the body mass. So I'm purposely showing you a slightly more complex example because this relates to the GAZE guidelines, which say that students should have experience with multivariable thinking. So we shouldn't just be thinking about one variable at a time, we should be thinking about relationships. And so this is showing the relationship between a categorical and a quantitative variable by breaking down the mean by that group. And I think it's much harder to do that procedure in base R. If we look at a simple scatter plot and look at the 3 ways, base R, plot, penguins, $ flipper length, comma, penguins, $ bill length, maybe that's not that complex, although it's a little repetitive. Every time you need to reference the data set, you have to put the name penguins. The formula syntax would either be something from lattice graphics like XY plot or something from GG formula like GF point. So GF point, bill length by flipper length, comma, data equals penguins. And the tidyverse would be something like ggplot of penguins plus geom point, AES, x equals flipper length y equals bill length And again, if you're interested in the ways that I'm speaking this code aloud, you could go check out that talk from the summer of 2020, but you can probably see that I'm dropping some characters, but I'm trying to be as explicit as possible when I'm reading that code to you. If I had to go one step further and make sets of scatter plots, so I want to know if the relationship between flipper length and bill length is the same for each of the 3 species, it gets very complex in base R, very repetitive. Maybe there's an apply solution, but I don't know what it is. But it's relatively straightforward in both formula and tidyverse syntaxes. So formula GF point of bill length by flipper length broken down by species, comma, data equals penguins, and then the tidyverse, we add things on using the plus sign. So ggplot of penguins, AES, x equal flipper length, y equal bill length plus geom point, plus facet grid, tilde species. So I think that you can start to see that the formula solution tends to be the most concise. The tidyverse syntax is a little bit more verbose, but it's not as verbose as the base syntax. So then the question is, which one should we be teaching? And I was inspired by some work by Andreas Stefik and Susanna Siebert, where they were studying programming language syntax. So this is not in the context of R, but they tried comparing languages like Ruby, Java, Perl, Python, and then they threw in a new language, which the researchers were working on, called Quorum, and then they put in a placebo language that was called Randomo. And Randomo is just random characters. It doesn't have any meaning in English, and it's just characters. And what they found was that languages that used the sort of C-style syntax, Perl and Java, didn't give any higher accuracy rates than the random language. But languages like Python and Ruby and this new language Quorum, they did afford better accuracy. So from that study, they were able to show that Quorum was maybe a better language to use, and perhaps Perl and Java were very difficult for learners. And there's similar conversations that have been happening in the statistics education community. So there's debate about which R syntax is the best to teach, particularly when you're teaching a first course. So an introduction to statistics course where you're using R as the sort of statistical computing tool. When should you be using base R? When should you be using tidyverse or formula? So all three of these syntaxes have their proponents. The base first philosophy, I think, comes from people who learned base first, and they often learned using the documentation from R. There's a man page that starts with, like, here's what a vector is, here's a matrix, and it's sort of a programming approach to learning about R. I've heard a good argument from Jeff Leake about using base graphics as a way to do exploratory data analysis, but in terms of arguments for using base R in a first course, I haven't really heard any arguments that are grounded in pedagogy. Many people who try and make this argument are trying to troll and start an argument, but they don't really have a justification as to why it would be better for learners. On the other hand, the tidyverse and the formula proponents, I think, both have great points. So the tidyverse first philosophy, I think, gets espoused by David Robinson. He's written a few popular blog posts about it, and he gave a talk at RStudio Conf. Mina Chitenka-Arundel has this Data Science in a Box website, and one of her arguments there is start with cake. Start with the good stuff. There's no need to start with, here's a vector, here's a matrix. You should start with data visualization, and her materials start with the tidyverse. And then there's the formula first philosophy, and Nick Horton calls this the third way in this blog post that I've linked. And this is the philosophy that led to the Mosaic package. I think that Randy Prime is the first author on the Mosaic package, and then Danny Kaplan and Nick Horton are also authors on it. And the Mosaic package aimed to make formula syntax something that could be used throughout the entire introductory statistics course. So I've taught R a lot over the years. I've taught introductory statistics labs that were completely in base R. I've taught them completely in formula and completely in tidyverse. And if you take one thing away from this talk, it's that I believe that you should try to be as consistent as possible. And this is really difficult if you're someone who's used to mixing and matching syntaxes, but I think that it has really good benefits for students. So I've taught all of these in the past. The problem is that I would pick a tool for a particular semester, and then I would write materials for that semester. And I would be unconsciously modifying the tasks that I was assigning to students or the things that I was doing because they were easier to do with a particular syntax. And that makes it really hard to compare which one is actually better. So there's been relatively little evidence that has been gathered on this regard, but there is a paper. The first author is Timothy Rafalski, and Andreas Stefik is also on this paper. This is sort of his research group. I'm a co-author as well. And this was comparing those three R syntaxes. So this was an experiment in which they showed participants a few examples of using a particular syntax. This is the formula syntax, which they're calling the tilde syntax. And then they say, here's a new task. It uses the same syntax. See if you can do it. And then you can see up near the top in figure 3, there is an example of errors from a participant's code snapshot. And then they compared for completion time and number of errors and didn't find any statistically significant difference between the 3 syntaxes. So I thought that that was pretty interesting. I was expecting to find that base R was worse, but that didn't turn out to be the case. And one of the things that I noticed when I'm looking at this example is that there's some misunderstanding about data set and variable names, which I think is a really common misconception. So in the first line, the participant almost has it, and then something is a little bit off, and they're trying all sorts of things that would never work in R. So looking at this paper, I saw misunderstanding about variables and data frames, and I also was thinking, well, they didn't do any teaching. They just said, here are a few examples, you need to glean the pattern, and then here's the test. But they didn't have any explanation of what it means, how you read it out loud, where pieces go. So as another experiment, and I'm putting it in scare quotes for a reason, I decided that I would compare the 2 syntaxes. So in the spring 2020 semester, I had my first opportunity to teach introductory statistics labs at my current institution. And I thought a lot about whether I should teach formula syntax or tidyverse syntax. I couldn't decide, so I thought, why don't I just teach both? Which of course doubled the amount of prep work that I needed to do. So I decided to teach one of my 2 labs completely in formula syntax, the other one completely in tidyverse. And at St. Thomas, the lab assignments are standardized across all of the labs, no matter what technology is being used. So we use JMP, SPSS, Minitab, Excel, and R. And that meant that I had to write my pre-labs to teach students the skills that they needed to accomplish exactly the same tasks in both syntaxes. So this made it really easy to compare between them. And I did get IRB approval to study the experiment. Of course, spring 2020 was the semester where COVID hit. I started teaching in person, and then I had to shift to teaching online, and the data just was not really usable at the end of that semester. So I repeated the experiment in fall 2020. I'm still working on the data analysis. The reason that I agreed to give this talk was I thought it would motivate me to do it, but it's still in progress. And through doing the data analysis, I realized it's really more of a case study than a true experiment. So I did randomize which lab was tidyverse and formula by using a coin flip, and I attempted to switch each week which order I wrote the pre-labs in. So one week I'd write the tidyverse first, and then the formula, and the next formula, and then tidyverse. When I started recording videos, I tried to record them in different orders. It didn't always happen. Of course, students had to consent to participate in pre and post tests, and then I can also look at their work. So if you want to dig into the materials, I've put a page up on my website which has the content from each one of the labs. It links to appropriate RMarkdown documents. It has a YouTube video that you can follow along with. And then if you just want the RMarkdowns, they're on my GitHub, and the videos are on YouTube in a couple of playlists. So what did I find? Well, first of all, the prior experience of my students between the 2 labs was pretty consistent. So most students had never programmed ever before. Some of them said that yes, they had programmed before, but not in R. There was another option that they could have said yes, that they had programmed in R, and no one chose that. And the other languages that people said that they had experience in were things like C++, Java, JavaScript, HTML. I had a few computer science majors. And there's maybe a little bit of difference in terms of the prior experience between the 2 labs. And I also have pre and post data, but I don't think that it's that useful. My sample sizes were very small, and then some of these actually seem to have gotten worse. I was using questions from the Software Carpentries pre and post test, and I don't think that that was particularly useful for my context. So the first one is using a programming language like R can make my analysis easier to reproduce. It looks like maybe that got a little bit better for formula, maybe it got a little bit worse for tidy, although there's more people who strongly agree. When working on a programming project, if I get stuck, I can find ways of overcoming the problem. Both groups got less confident in that. I'm confident in my ability to make use of programming software to work with data. It looks like that one, there was improvement in both groups, so that's good. Using a programming language like R can make me more efficient at working with data. Not much change there. They agreed with me before. Having access to the original raw data is important to be able to repeat an analysis. Looks about the same. And then I know how to search for answers to my technical questions online, and that maybe got a tiny bit better, or maybe it got a tiny bit worse. It's interesting to me that the formula seems like it maybe got worse and the tidy maybe got a little bit better, but I don't think that any of those differences are statistically significant. I also have other data that I haven't analyzed yet. I have data on viewership on my YouTube videos for that period of class, and I could see how much time people were spending on videos and if there was longer viewership on one or the other syntax. And I also used RStudio Cloud, which is a cloud-based version of RStudio, and I have usage analytics, so I can look to see how much time students were spending working on the labs, which again are very consistent between the two different labs. And that analysis is still in progress. So if you're interested in the topics that I covered in the labs, again, they were standardized. I couldn't change what I asked based on syntax, and the lab topics were starting off just, what is data, what are variables, what are observations, exploratory data analysis for one categorical variable, two categorical variables, one quantitative variable. Then we do correlation and regression just as a descriptive technique, bootstrap intervals and randomization tests, so simulation-based inference. Then inference for a single sample and inference for two samples, and that's using distributional approximations. ANOVA and chi-square, and then back to regression with regression inference. And again, all the materials are available online if you want to look at them. So at the beginning of the semester, I gave all the students an all the R you need cheat sheet for the semester. So there was one for formula, one for tidyverse. And every week I gave students an RMarkdown document that contained a pre-lab for the week. So the pre-lab, it had text, it had some code, it also had blanks that students needed to fill in, and it covered all the material that was needed for the real lab. So maybe descriptive statistics and visualizations for one categorical variable, but using a different data set than the one that they would have to use on the real lab. They also got a link to the associated YouTube video, and I sent this all out on Canvas. They were expected to work through that pre-lab material asynchronously on their own, and then right ahead of the lab time, they would get another RMarkdown document that had the real lab assignment, and again that had blanks and sort of some structure. It was a skeleton. Then I would have synchronous class time on Zoom, where I would answer questions about the pre-lab. I'd help make sure that everyone could get the data loaded in for the real lab. I'd give them any little tips or tricks that I thought that they needed, and that probably took like 20 minutes. And then the rest of the time, which is like more than an hour probably, because the labs are relatively long, I would just answer questions live. So I'd open up some breakout rooms because some students liked to sit in a breakout room and work with other students. Some wanted to work alone, so they'd drop out of the meeting and just come back if they had a question. And I would answer questions as they arose. And one detail here is the students were writing in RMarkdown documents, but they had to submit the knitted version of the document. So that's the kind of compiled, finished version that has the nice headers, it has the code, it has the output embedded in there. And that is good and bad. One thing that's good about it is it meant that there were never any syntax errors in the work that students submitted, because they needed to get the code to work in order to get the document to knit in order to be able to submit it. But then that meant that if they got stuck on something, they were really stuck and they sort of got no credit. The other thing that was complex is we were using this cloud-based version of RStudio, and that meant that they had to move files from the cloud to their local computer, and that is a major source of confusion for students. So I just want to show you briefly what I mean about these all the R you need cheat sheets, and I think because it's a virtual talk, I will show you in RStudio. So here we are in RStudio, and maybe I'll start with the all the R you need formula. This is itself an RMarkdown document, so it starts with a little bit of a header, but then it just gets right into, we're going to use these 3 packages in the course, and every lab we just loaded these 3 packages. It was extremely consistent. I show them how to read in data, and I used this example data set for all of my pre-labs for the whole semester. It's from the General Social Survey. And then it has sections like plotting. So it will show you how to do a bar chart for 1 categorical variable, for 2 categorical variables. What if you have a numeric variable? Well, you might make a histogram or a box plot. What if you want to make side-by-side box plots or a scatter plot? And this code is all in chunks, so it should be executable. And then it goes through things like summary statistics, how to work with data, things about modeling like linear models, predictions, bootstrapping, tests for proportions, t-tests, ANOVA, chi-square, and a little bit of probability. And then the tidy version, all the R you need for Stat 220 tidy, is very similar. It's got 3 packages as well, although they're different. And I'm using the tidyverse package. This is sort of a convenience package that loads a bunch of things, so it's a little bit of a cheat, but I liked keeping it consistent that there were 3 packages for each section. I read in data using the tidyverse version, read_CSV, and then the same sections, the plotting section for 1 categorical and 2 categorical, 1 numeric, side-by-side box plots, scatter plots, summary statistics. And I think you're starting to see one of the things that is tough about the tidyverse syntax is that summary statistics are very verbose. We've got some stuff about working with data, and now we've got modeling, bootstrapping, test for proportion, test for mean, ANOVA, chi-square, and then a little bit of probability. And I'd like to focus on a couple tasks just to show you the contrast between the 2 syntaxes. So I'm going to start with the bootstrap. I think this is a good topic because it's something that you can't really do if you're not using a computational tool in your statistics class. And I think that it helps develop intuition, at least if it's done right. And so then the computation can help support the statistical understanding. And again, I think I'm gonna swap over to RStudio so that I can really show you how it works. I think I'm gonna live code this, so I will close up those RMarkdown documents and I'm just gonna work in the console. So I'm gonna start with the tidyverse. I'm going to library tidyverse, and I'll get a few messages here. I'm going to library infer because that's the package that lets me do simulation-based inference in the tidyverse. And I'm going to need to library Palmer penguins to get those cute penguins. And now I'm going to make an object called boot. And what this is going to be is it's going to be penguins. And then I'm going to specify that I want my response variable to be flipper length And then with the pipe, I'm going to generate reps equal 1,000, 1,000 repetitions of type equal bootstrap. And then I'm going to calculate the stat equal to mean. And oh, that happened extremely quickly. Sometimes it takes a little more time because it has to do it 1,000 times. And now I might want to do a ggplot of that boot object plus a geom histogram AES x is equal to stat. So I'm gonna make my plotting window a little bit bigger and you can see my bootstrap distribution. So I ran through that very quickly. I would obviously go much slower if I was teaching a class, but I think that you can see how the syntax kind of captures what happens in the bootstrap. You specify, you generate, you calculate, and then the plotting is a separate step. The approach in the formula syntax is similar, but it's different. So I'm going to try and do that now. We'll see if I get any conflicts for packages, but I'm going to library Mosaic because that's the one that is going to have the formula syntax. And I'm also going to library ggformula because that's the one for graphics. So this time I'm going to overwrite my boot object and it's going to get do 1000. So I'm going to do something 1000 times, asterisk. So it's kind of like times, but it's overloading that symbol. I'm going to take the mean of flipper underscore length underscore comma data is equal to a resampled version of penguins. And I happen to know that I need to na.rm equal true to get this to work. So let's try that out. Again, now I have a new object. It's called boot. It's got 1000 observations. And now I'm going to do a GF histogram of mean data equal boot. And again, I know what the names in these objects are going to be called, so I can do this pretty adeptly. But again, this is helping to capture some of what happens in the bootstrap. You do something 1000 times, and what you're doing is you're resampling from the penguins dataset. So I think that both these approaches have a nice syntactic meaning that connects to English language meanings and to statistical meanings. Okay, so I've shown you one case study, but there were obviously weeks and weeks of labs. And what was easy with the formula syntax? Well, it was really easy to introduce things like LM for linear model, AOV for analysis of variance, chi-square.test. After students knew things like mean and core and GF underscore point, because the syntax was so consistent. So if you look mean bill length by island, that's the same syntax that you would do for AOV, bill length by island. And that makes sense. We're breaking down the mean by island, and then we're doing inference about the mean broken down by island. And same thing with the correlation. Core of bill length by body mass G. I could do the same code basically inside my GF point to get a scatter plot of those two variables, and I could do the same thing inside LM to get the linear model. So that was very consistent. It was also easy to do inference using distributional approximations. There's a formula syntax to prop.test, t.test, and so you can use that interface. But what was hard? So dealing with NA values was hard. I made a miscalculation in spring 2020, and I showed a way to set a global option in R. That was a mistake. But even if you're just going to deal with it on a per function basis, it's hard for students to remember that they need to do na.rm equal true. And then even worse than that, if you're going to do something like correlation, the way that NAs are dealt with is different. And then even worse than that, there are things like prop.test from Mosaic, where you can only work with data that has 2 levels. It has to be, a difference of proportions. And so if there's an NA in one of your variables, then you get an error. And this is going to require some data wrangling. And data wrangling is something that isn't specifically in formula syntax. So if you want to do data wrangling, then you have to introduce dplyr verbs. You have to decide, are you going to show the pipe or not? Another thing that was really hard was getting long variable names correct. So for the most part, I've been showing you examples using the penguins dataset. But my example dataset was from the General Social Survey, and I had variable names like highest year of school completed, and then highest year of school completed spouse. Notice that one of those has an of in there and one of them does not. And if you're using the formula syntax, RStudio does not do tab completion. It doesn't suggest what the variable name is going to be, so you have to type it out very correctly. But that's not really about the syntax, but it is something that was challenging for students, was making sure that they got things very correct without having the help of the tab completion. What about the tidyverse? What was easy? Well, explaining concepts like bootstrap and randomization from the infer package. I feel like that really was consistent with the rest of the syntax. It was pretty easy to deal with NA values. Students got used to this pipeline, and so just inserting another piece into the pipeline to drop NA values, that made sense to them. When we came to the end of the semester and students were doing projects and they had to do data wrangling, again, even if it was syntax that they hadn't seen before, it made sense to them that they were going to put something into their pipeline, and it was pretty easy for me to verbalize code to them over Zoom and for them to type it in. Okay, what was hard in the tidyverse? Well, one thing is summary statistics. Summary statistics are way more verbose in the tidyverse. So this first chunk of code is basically coming up with the proportion that are in each island, and that would be one line in formula. It would be tally, parentheses, tilde island, comma, data equals penguins. So this is much more verbose. Another thing that was hard was explaining the difference between the pipe, which is the percent greater than percent, and the plus operators. So sometimes when you're sticking things together in a pipeline, you use the pipe, and then when you're doing a graph, you stick things together with the plus. That, if it had been consistent, I think would have been easier for students to grasp. And sometimes they just thought that they needed to throw pipes or pluses kind of everywhere. Like with pipes, they would often just try putting one at the end of every line. So they didn't really get the idea that it was piping data between operations. Another thing that was hard was inconsistency when we got to modeling using LM and AOV. I didn't venture into tidy models, which I think is maybe a solution to this, but I did have to introduce formula syntax in my tidy labs to be able to do linear modeling and analysis of variance. And so unlike in the formula syntax where the mean and the correlation really looked like the analysis of variance and the linear model, the mean and the correlation look totally different. It's not the same syntax at all. And then there was also this challenge with using distributional approximations. The infer package was designed to help with simulation-based inference, and it hasn't had a focus on distributional approximations like the normal or the t-distribution. So when I taught the class in spring 2020, there was a chi-square test in infer, but not a prop test or a t-test. So I had to work around that, and that made things even less consistent. But by fall 2020, they had implemented those two functions, but I found even more edge cases. So that's a link to a GitHub issue, and I think that that issue has been now closed. So it's currently under development, and I think that it will improve. Another thing with infer was that tab completion was tough. Maybe I'll swap back to RStudio. So I'm just going to hit the up arrow here a couple times to get back to my code where I did boot penguins, and then I specified and generated and calculated. And then I'm going to make a ggplot of this. So I'm going to do a ggplot of boot plus a geom histogram, AES, x is equal to, and then the variable is called stat. So students in the tidyverse, they had this support of tab completion. So they were used to, with my long variable names, getting to hit tab. But if you start typing stat and then you hit tab, you get stat open paren, close paren, which is a function in R. And if you hit enter, you're going to get a very weird error. So students had to recognize that those were extra parentheses and take them off. Sometimes RStudio is too helpful, takes off too many. And so that weird little tab completion thing tripped students up for weeks on end. Overall, things that were easy for both labs, explaining RMarkdown, I really recommend you learn it if you don't know it already. It's pretty easy to debug with hands off the keyboard if you're good at verbalizing code. Even if you have to do it online, you can keep your hands off the learner's keyboard pretty easily. The hard things, variables. So that study that I was talking about with the 3 syntaxes that Stefik et al. Worked on, I thought that there was, some confusion about variables. That confusion persisted even in my semester-long courses. So for example, with the penguins data, there's a variable called species, and it has 3 species, Adelie, Chinstrap, and Gentoo. And students often thought that like Gentoo was a variable, and they'd try and write it into their code instead of writing, that I want to break this down by species, and understanding that R would do the breaking down for them. Like I mentioned before, moving files to and from the cloud was very hard. File paths are a persistent issue. And then students using the internet to troubleshoot. Because if you Google something, you're probably going to find something in a different syntax that you haven't seen before. I think that kind of explains why students got less confident about being able to search online over the course of the semester, is because if they tried searching things online, they found something that looked really different. I will say that in my post survey, I asked students how the experience of learning R was, and most people either said not what I expected in a good way or about what I expected in a good way. So most people seem to have a positive experience. And I asked them, would you have preferred to learn the other syntax? The majority of students said no. And then I asked them why or why not. Sometimes they had a reason, like I heard that formula was more straightforward, so I'd rather have learned that. Or I thought that the syntax I learned worked well. I enjoyed the tidyverse, tidy is tidy. But many students said, I don't know what the difference is. You didn't show me the other one, so I didn't have a preference. And someone said, I wish we got to experience both. If I got to do it over again, I think I would maybe have shown them a little bit of the other syntax in my post survey. I would not have taught one half of the semester in one and one half in the other. I don't recommend that. And probably I would have asked some better questions in my survey. So the question is, what syntax should I use? I still don't know which one I would recommend. I think it really depends on your use case. The formula syntax felt more consistent for introductory statistics. The people who've worked on Mosaic and ggFormula have made it such that an entire semester in intro stats can be taught in that syntax very consistently. Those students didn't see any dollar signs, they didn't see any square brackets, they didn't see the pipe, and almost every function that they saw used the formula interface. So that was great. The tidyverse syntax is maybe not quite as far in terms of being super consistent for introductory statistics, but it feels more useful to me. It's much more broadly used in the bigger community. It's something that students are more likely to see as they go on. And I think that it's more useful for things like data wrangling, which is a major part of doing any data science or statistics. So I don't have a strong conclusion for you at the end of this talk. My main recommendation is just be consistent.